Hello. Hi. Sorry, my voice is terrible. I'm hoping that everyone can hear me. If you can't, let me know. Welcome to my talk. It's about observability. I don't know if you have heard of that before, or this is kind of an introduction, medium, or kind of advanced level. I just want to understand how many have you worked with, kind of, or day to day, you know what observability is. Good. At the end of at least at the end of the session, we will be on the same page. What does it mean? What do we do to get any system observable? The topics, actually, I will be covering everything except PowerShell. Jeffrey Snover is not here. Kubernetes, distributed computing, Istio, which is kind of comes with the service mesh. The best-selling product of it right now, and as a MOI, the sidecar. Who am I? I'm possibly the only Turkish vegan in London. I used to be a .NET developer and turned into DevOps, automating things. I'm working as a DevOps consultant at Cucen, and I have a 6-year-old son, also making me up, and proud wife because my husband is taking care of him for the whole week that I'm enjoying Seattle this week. I love exploring, learning. I used to be running a London.NET user group with Gail and Daniel, if he's here. Today I'll be talking about the definitions to make sure that we are on the same page. What are the differences with the monitoring, so why monitoring is out and what we are going to do. A bit history about application life cycles, what happened and where we are, the theory of it, and I will have 2 demo sessions. Monitoring, as we kind of the definition, getting it right, is about collecting your data sources. So you have to know what data sources you have in advance. And you do process this data with aggregations or other kind of algorithms that you do get the usable pace of it, and then you display on a dashboard or real-time display so that you have the full picture of your predicted environment's output on a monitor or a dashboard. So you can get the query counts or types, error counts or types, processing times, server lifetimes. These are all the bits that we used to do for years. It is called black box monitoring to differentiate. Years back, this kind of item, black box monitoring versus white box monitoring started. The black box was for the structured logging, well-defined metrics, and the tracing, so that you know the predictable features. You have to log them before. Application developer had to write this is going to fail, so I'm going to log this. This is going to happen. So you have to know what you are going to fail. And in terms of the Snavix or Nagios, old kind of monitoring systems, you had to write the checks. This is going to be kind of up or down. So you have to define before what's going to happen. And the tracing is the records, each request lifetime. You had to know what the performance issues you may have. This is an example. I put everything that Azure for a VM, you can log get monitoring. When you say Azure monitoring of a VM, these are all the agents you can get. But none of them makes you observable. So this is still not enough. So something is hard. There are Azure resources, the metrics, diagnostic logs, all kind of log analytics, workspace agents, and other things happening. But still, they are not observable. You can't make the system observable. The difference between metrics and logs, everyone is happy with that. Do I need to make the difference? Metrics is the telemetry, so it happens whatever your sampling frequencies, whereas logging happens on a response of an event. So you have to trigger and you have to log it. So why this is not enough? Because the structured log, what we had before, it wasn't scalable. So when you had millions of records coming in, your logging system may not be covering it or responding in time. There is no scalability in your logging systems. They just log, Windows event log or anywhere. Well-defined metrics, up doesn't mean it's working. If you get 200, but the page is not displaying what the customer wanted, it doesn't mean. And with the, I will tell in a bit, with the containers and the Kubernetes clustered environment, rather than being up or down, we have readiness and liveness checks. The probes and the naming kind of conventions has been changed. It's not anymore being a system up or down. And the tracing is partial of it. You have to get the metrics with the date timestamp of the whole request from the end user to the, but it's just part of the system. It's not the whole environment, the system talking to each other. So on the distributed kind of environment that we are getting, because it's all distributed, we need to think about more. And the monitored metrics we thought about before is not relevant anymore. This is from Google's SRE book, which made SRE word popular. What do we know? How can we improve the metrics? So instead of taking up and down, you need to take care of your latency. How many requests are you getting per second? Or what's your traffic? How many requests are you getting per second? Sorry. Errors, how many errors you have? What kind of them are 200, 300? It's not just 500 server errors, but you have to think about custom rules on your errors. And saturation, how many of your applications or VMs have, or kind of environment being used, consumed. So these are the things you need to think about with the new design, but still, it's not observable. Charity Mayers, who made this observability popular, says nines, kind of how many nines you have doesn't matter if your customer is not happy. You can calculate all design the architecture with how many kind of nines you are going to have, multiply each one, say that this is my uptime or the availability. Doesn't help the customer. So this was the black box, we said it. Someone came up with the idea of white box monitoring. Something will discover it rather than you define it in advance, rather than someone writes the VM names, application names, checks to a list, to Excel sheet and convert it, or your PowerShell scripts, kind of automate them. Something should need to discover it and understand what's going on within that system. So even if we add a couple of things, we are kind of getting to the observability part. Observability is a noun, the main difference, taxonomy, and monitoring is verb. That's the main difference. When you observe, you actually monitor. The basic is the same, but observable means it's a property rather than a verb. So it's the action or you take to check the system in advance. Observable is the noun the system displays, so you don't have to do anything. So if your system can display outputs without your action, then your system is observable. So it's attribute to check the behavior. Whatever I add, hairs, kind of unicorns. If you said monitorability, we may kind of get the same word, but hey, we need fancy words, we need new tools, someone should sell it. So it's observability, we have it, rather than monitorability, which does the same thing. It is a noun, and it does do the same job. So the definition of observability comes from the control theory. It's a mathematical control theory, so that the system should be able to define by the outputs display. So you can determine the system's state without touching it or without modifying, understanding what's going on inside. It's the inside system displays and shows what's going on. And of course, because it's DevOps, it's part of the culture. There's DevOps observability team. It's about motivating this. There are also movements across getting this team culture, making sure that everyone with the whole organization, because it's, again, end-to-end, shifting left, the business does understand what your observable system is. Most of the time I see companies that just focus on still developers or the applications, but we need to get really the system displays value of the applications or the environment. How many kind of what's your earnings per year or per month, per minute. You need to understand, if you're a bank, you have to understand what your inputs are. And this is policies of distributed computing. It's 1994, the first 7 has been written, about 25 years back, and by Peter Dodge and James Gosling. If you know, he's the father of Java. He added the last line, the 8th one, so there are 8 policies of distributed computing. Right now we do laugh. At the time, possibly people didn't, but this is where we are coming from, the monolith applications to distributed applications. So at the time, we had the network reliable, we assumed, but then what happens, the VMs stop. Someone should go and take the action. It doesn't respond all the time we want it. Latency is 0. What happens kind of if the package or the packet drops on the way? Do you take any actions? Bandwidth is infinite. Still, people do argue with this right now, saying that, hey, we have every year, every 2 years, increase bandwidth, but the demand is increasing as well with video streaming and the VoIP systems demanding more. Network is secure. There are still vulnerabilities, even if you assume your system is HTTPS, you have implemented the SSL, TSL, all your applications. There are still vulnerabilities, and people are being tracked down, not being a secure system. Your topology doesn't change because all the systems in olden days, we had the Excel sheets. I don't know if anyone knows. We had all the IP addresses and the DNS names. You need the whole network topology in your hand that nobody is allowed to change it. There is no dynamic kind of provisioning of the VM environments. But now we have the kettle, so we don't do pets anymore. That we know what's going to happen with that topology. There is one administrator, which is the team responsible for it. One team should define the NSG rules or whatever the network rules. But then now developers or everyone in the system started to make requests for the changes, and there are conflicts start happening that you need to understand what the kind of consultation process for your traffic rules going to be happen, because it's the whole company going out and coming in, all the traffic. The transport cost is 0. This is partly interpreted as that you need a network, you need to lay out, which is not the case anymore because it's all cloud. But in terms of the input-output I/O CPU, still we need to pay for the money. And the network is homogeneous, is not relevant anymore because it's all heterogeneous, even when you're at home. These are the kind of not relevant anymore. Just as a history, where kind of what happened in terms of distributed computing, I get 3 groupings. The team or the logic with the XP and Agile Manifesto was 1999, 2001. So the monolith applications, rather than delivering bugs more frequently, is delivering MVP so that we get frequently feedback from applications. That is about 15 years back. And then 2006 is when the first AWS had the EC2 instances. Automation and provisioning that we get rid of our previous assumptions. 2009, when the first DevOps word was coined. 2010, when Netflix moved all their applications to AWS and became the cool kid block. 2012, the first time microservices were defined as SS on the ThoughtWorks radar. I don't know if anyone is following it or reading. Every quarter they do publish, and it is quite industry-leading report that you may want to see or read through. They do assess the tools. In 2013, Docker was announced. 14, the microservices define at the Martin Fowler's website what does microservices means. And 14, we had the Kubernetes coming in. I had a funny demo. It does involve balloons. We don't have to do it. Michael will say we have to do it. It's basically it's kind of, should I do it?
Yeah,
Can someone say no? Oh, okay. Michael, you have to come help me then. Stop. Here or somewhere.
What do you need me to do?
Just a big balloon.
Okay.
Very big. And we will tell him to stop when it's. This is the monolith. This is possibly 13 years back. My banking software, I went to Bucharest, Romania. 12 months, 10 developers. We had the banking application to be deployed. It was debit and credit systems. That's good. 12 months, I've been told that I'm going to do the release for 1 month. 2 weeks before the release date, 2 weeks after the release date to fix the release. Yep, that's good enough. Yeah, we can keep it, yes. It's 12 months of kind of work has happened. There were bugs, things happened, we fixed it, but yeah, thank you. Not finished. So, sorry. So this is old style, what we were used to do. And this is some people decide to say, hey, microservices.
Nope.
I said explosions, not broken glass. Some people invented microservices. Hey, I can have smaller to fit in this one. Sorry. I can have kind of smaller applications because if this is the backend, frontend, and the database or the middleware, I'm thinking of the end tier first, so I can divide into 3 pieces, and then it wasn't enough. I have to do microservices. If this is the retail application, I think too big. Maybe even itself, just one small. Oh, I picked them too big. Or itself just.
Yeah, I'll just try.
Okay, sorry. So yeah, people said that if I'm retail, rather than thinking that I'm doing the front end, middleware, and the back end, I can do product page, I can do checkout page. So each page or each change in the system is not impacting. Because for this one, if I want to change anything on the system, the network, in a sense, comes in and comes out. The change comes in and change. I have to talk everyone who is involved, the database, the administrator, the backend, the front end. If I want to implement any change, it doesn't work.
Well, it undid itself after I got it in there.
Terrible idea.
Good enough? There you go.
Thank you. Yeah, so people said that before putting in, sorry, I have to show it. Yeah, we have more. Thank you.
Yeah, no, that's good.
So this is a kind of my product page, right? Or if it's a book application, I'm selling a kind of book. So I'm a bookstore and selling books online. So this is my review page. There are product pages. So we decided to distribute it or divide the team with specific dedicated nouns. And we call them domain-driven design. So each one will be a domain. This is my product. That will be my checkout. Each one will have their dedicated role or bounded context, so that whenever happens something, they will be happening within this. Sorry, before putting. I said some explosions, man. So this is each one. Thank you very much. No, go. No. These are the kind of my dependencies on the system. So each one, my bookstore, let's say, if I have the product page, if I have the reviews page, if I have the checkout, ratings page, whatever, they will be all independent to each other. And which team wants to modify, they can just modify it. But it wasn't enough with this distributed system. Because what happens, product page goes down. What happens, and the number of the microservices increase, the connections between them, talking to each other made a big kind of disaster as well, that who is going to be responsible on which. And each one depending on each other, there are multiple strings, which I'm missing right now, that they will all kind of fall apart. So they decided, let's put this in a container. So we had pod, and this is my, let's say, product page or product service. So because it has an API, it has a contract, it will connect all the other applications, all the other services. So let's say this is the product service. Awesome. And I have 4 of them. I can't put it here. So thinking about the 8 policies that we had, each one talking to each other, secure how they are going to talk to each other. Now we are talking about serverless, it's becoming a more issue. And thinking this pod will give it the logic whenever instance dies, the inside it will be created another one. So it will be always up, in a sense. So my product rating reviews page, let's say, they will be all working. So the difference where this observability things became popular, this is microservices, they think they are working, it's okay. It wasn't. The issue came when I can't understand the system coming, and the dependencies between them is still not managed. It's still too complicated, and if one of them fails, I don't know which one to talk to. They are still critical. So someone came with an idea. This is the containers inside the pod. Rather than doing this, I'll put a sidecar. Sidecar is very similar to your application in a sense. I didn't tell you this story. This is my... No, I didn't give him brief, so... Yeah, I'll get that. Thank you. So this is my sidecar, in a sense. Thinking the... color aware would be nicer, but let's say... That's fine. So I'll get the blues as a sidecar, which gives the idea to the controller. So whatever my system is not reliable or happening, my sidecar will take over. It is responsible for all communication, authentication, whatever happens, it will know about it. And it is the only one to communicate as well. So my other service is not allowed to talk to anything. And the third sidecar. What we call as observable is actually this sidecar. It gives all attributes, the nouns I was talking about, to the outside world, so that you do understand what's going on in the system. The system does talk about itself to the outside of the world. So each one, the blue one, is a sidecar container, in a sense, and gives all the information about the system, because it's the whole controller. It knows who is coming in, and it knows who is going out. If you think there's a string as well, the only communication between them is via the sidecar. I have it as well, but it's going to be just, I don't want this just good. Yeah, let's ignore that one. But I think everyone now is clear about what's how. I didn't tell you about the namespace. So the other failure was, okay, this is my product page. But as a company, we may be doing multiple projects or products, applications. It doesn't have to be, or my company can be selling books. This is the bookstore. It could be having a car website. It could having kind of another retail site. So, or there are multiple applications. We need to put them together as a cluster. It's called namespace. So I know now, whenever I call this book info, which I will show you, the book info will be about the books. So my namespace, in a sense, the orchestrator behind it will be understanding and talking to each other within the environment. So I have a namespace. Inside it, there are pods that communicate. Each pod has one or more containers, and it will have a kind of sidecar to be responsible for all the communications outside and inside. I'll go into detail. But this is the kind of microservices I tried to show before the sidecar. So each service itself was responsible about the discovery, its load balancing, resiliency, what the metrics I'm going to send out, and what's going to be my tracing. But it wasn't enough, as we say. If one of them fails, you lose track of communication. It's hard to administer. And as a network topology, it is not, it's just administration overhead. And then it's one of the network topologies, mesh topology, similar to, or the other options are your tree network topology or hierarchy. The mesh networks is make sure that it's, who has been to the Zookeeper, Apache Zookeeper session this morning? It was an awesome session, by the way. If you find the recording, please go and watch. He talked about all this leader election and how the clustering works. With PowerShell, he has proper PowerShell examples as well in his session, how you keep up and make sure that all the systems, all the services are connecting to each other. It is part of implementation on top of it, but I'll be talking about as a managed service. So you don't have to think about defining the heartbeats and making sure that which service has died, I'm going to recreate them, or this service is not communicating with me within the last 3 checks, so I need to recreate it. Logic. So service mesh then is the common decision. It may rescue the world now. It will be leverage, automatically span the identifiers from the data plane. I'll talk about data plane in a sense, but it gives the observability uniformly across all, because I know that all my sidecars are giving me all the information they have. So it is uniformly and ubiquitously. It does make the connections. It's control of everything goes in within the pod as well, and security. So thinking old and new, this is the physical network plane. It used to be 3 layers. With outbound, you had to think about all the monitoring and the policies in one layer 4, focus. And the rest of it, the control plane, what the routing is going to happen, what my state file looks like for that network topology, was immanent with the service itself, which is the data plane, does just the packet forwarding between the services. So service mesh is kind of condensing that outbound responsibility to control plane. So we don't have a management plane anymore, but the control plane does take care of all the policies. In a sense, this control plane with my control container orchestration, that's what we did actually. With the pod A and the pod B, we had the proxy sidecar, which is responsible for all outside communications and make sure that the service has all the data and out we can take the data outside of the service as well. Yay. And now we are clear about what the communication and everything. Istio is the product, the popular. There are multiple options for it. Linkerd or Istio is the two most popular ones. I'll try to explain how it works in a sense. What the control plane, it's actually like the captain of the ship. It does define what my policies are. It defines as a policy file, in a sense, responsible for who is going out and which communication is done by who. And as a application namespace, whatever that namespace has, each service is talking to each other via the sidecar proxy. And each report, sidecar proxy is responsible for sending out to the mixer, which is responsible for all the Grafana or other Prometheus metrics is responsible for. And yes, this is a specific example for Istio, and it will send whatever data it has to the outside system, which I will show, hopefully. We'll see if it will work or not. This is the standard Istio's website. If you go there, the most basic example, but I think it will be nice to understand how it works. It's the booking application. So there is an ingress MOI, which they call as the proxy. And then there's a Python product page. It has as the application a Java backend, in a sense, the reviews page and the details page. Talking to the reviews page talks to the rating page. Let's see.
The black bars are the sidecars.
Inside it, yes. Not visible, isn't it? Oh, yes, we have a backup plan. I have the screenshots. I don't want to show them. Let's see, but I have, just in case. Who knows? OK, I have created already. My example is on Azure Cluster Service, AKS. So I created that already, which takes 20 minutes. I will use that one, but you can't see. I need to mirror now. Cool. Yeah. OK. So the first thing I did was to create the AZSK cluster, which is very simple. Kind of, you tell how many nodes it's going to have, which VM type it's going to be. We can actually make a quick sneak into it. Has anyone used AKS, by the way? Just to. Yeah. Are you happy? You don't have to. Yeah. So when I said AZSK create cluster, it does create one. Oh dear. So we actually define what this cluster is going to look like. You do define its basic metrics, and you can upgrade it, you can scale it, or you can make it auto-scale as well, depending on your. And whenever you define it, it creates all the related, auto-generated load balancers, high availability sets, everything behind the scenes in a calculated, but always starting with MC. Resource group. You can see what's going on. And I've been told, or you can't touch them in a sense. They are managed by Microsoft because they are managed cluster, not your cluster in a sense. But they do define the pools and the backend and the load balancer. So everything is predefined for you. You don't have to think about how my cluster is going to be managed. So let's get kubectl. I did install Istio with Helm. Helm is like NuGet package manager, so it does just deploys things. It has charts like templates. It's so you define your YAML definition for a chart. kubectl is the command line. Let's see how many namespaces I have. Book info is already created. I wanted to create now, but not all resources have a namespace. So in a sense, you can get other things like the policies and other environments will not have any. So with kubectl, in Istio, there are custom resource definitions. They do define what is, if you remember the previous picture, the Istio does provide kind of management, the control plane and the data plane. With the control plane, you had the pilot and all the policy managements. And if you go down, you have the mixer and other services. So this is all by just installing Istio, you get all on your cluster. This is my, for any cluster I want to have. It does auto add those facilities. MY filters being one of them, gateways, the HTTP instances, management of your API keys. If anyone knows Zipkin and other kind of monitoring SolarWinds for your displays. If I do it. This is where it will say I have already access. Can I say? Sorry? So this is label namespace is for my cluster. Istio injection. This is the sidecar injection. You can, I think from version 11 it's automatically enabled. It's going to be labeled. So from now on, when I install Istio, actually, if you look at 1.14, it's a basic download. Installation is not. With Helm install, it actually does other things. But you have the Istio 1.14. Under it, there are samples which I'm going to use. So the controller, in a sense, the executable is Istio CTL, does the job. Under samples, book info, the platform cubic book info that I will be looking at. If we look at just the YAML file, as sample as this, it defines the services, and there are 2 services and the deployments. Sorry, 3 services and 3 deployments. In my scenario, if you remember the design, that we were going to have the product page, the reviews page, and this is the details. This is the ratings service. 1 service and 1 deployment per each cluster, and this is the reviews service. So one of them will define what ports are going to open, and what my service is going to be called. And the other will be the deployment, as in how many replicas do I want. So this is sending to the cluster, making sure that there is always one replica up and running with the label of version 1. It does define where the container is going to come from and the image policy. Standard kind of deployment. If I say this is namespace 2, I need to get C. So I said, let's get this Istio guide. New booking form. What did I say? Is kubectl apply, meaning take this YAML definition, whatever my service definitions and the deployment definitions are, on this namespace, and output as a YAML is my extra thing, because I wanted to show you. When I do kubectl apply on a namespace that Istio injection has been enabled, it will define differently in the new bookinfo YAML. If I compare this one with my existing one, I just want to show how the sidecar injection is happening. It is automatically behind the scenes, the magic. And the colors doesn't help. Okay. Book info YAML. This is the default one. Right click. Select for compare. And the booking for 2. Compare with selected. So in a sense, other than the details, it does add extra last applied configuration details. On the right-hand side, we have the Istio injection enabled. So in this namespace, it does create self-link, the resource version, extra stamped with the annotations and metadata, because all its responsibilities talking outside about what it is, right? The nouns we were talking about. Times. And there will be a dedicated, yeah. So here, the details. This comparison is every time we do it. This is the details deployment. And there will be an extra container if anyone gets it before me. It's normally quite standard. This is it. Let's look at all the containers. Time's up. I'll show just one more to this story. I have taken more time than I should. The first time I apply the product page, these are the, when I do apply, these are the pods created. So each one, the pods details page, product page, ratings and reviews. One of them is pending. We can go and describe. Most of the time, I had the trouble with CPU. There was not enough the cluster to serve this specific pod. But possibly it will, they will be running. There are services, the details page, the product page, the rating, and the reviews on dedicated cluster IPs. I have deployments for each one that we have defined, either it's available or not. And there are replica sets. For each one, it defines how many replicas I'm going to have, the desired and the current. So it does know what's going on. If I check the Actually, I know why. Because I did book info 2 as a new set without changing my original portal node clusters. Now it's suffering hosting 2 of them. So if I go to my node, what are they? If I say scale, not 42. So now, yeah, because what I did is book info was already deployed. Rather than removing it, which is the clean way I should have done, I have created another one. On top of it, it couldn't hold it. So some of them couldn't come up. But if I say 9 or 10, I'm hoping it will be all. The idea was to go to this product page. Hold on a sec, I have the backups, right? So basic, simple for this one. Yes, the basic kind of. What I did actually get the services after the deployment. The idea is your system by default installation does create my Grafana, Citadel, Galley, which defines all the control level plane services. And KLE, Prometheus, Tracing, and Zipkin does define with my Istio outbound logging. And if I define and deploy a dedicated ingress gateway, because by default they are not open, it gives me a public API, public IP with the gateway URL. I can go to the website and display the page, which did work as a proof. And when we apply the gateway, it does create the gateway networking istio and the virtual service networking istio. This is the default cluster any Kubernetes cluster would have, and it has how many pods and how many versions it does allocate for each one. So, any questions? Sorry. Sorry? Portal, yes. This container service is in a failed state. Do you want to new support request? What do you want to see here? Sorry, no. As in the upgraded work, the scale. Possibly the scaling didn't work. Of course, it's not going to work. Current in use 20. Yeah, what I should have done, and then kubectl delete everything. Actually, I did everything. No resources found. But when I do list namespaces, it does come with the namespace, so it's a problem to be solved another day. So. But thank you for listening.